students, welcome back to 60 out of 60 in KCET Chemistry 2025 series in just 200 days. So we are done with the first chapter of PU1, that is some basic concepts of chemistry, and today we are going to start the second chapter of PU1, that is structure of atom. Okay, so in today's class we will be discussing about the discovery of subatomic particles and about atomic models. Okay, so and please join our WhatsApp channel. The link of the WhatsApp channel is there in the description section, so you can join there and click on the link and join our WhatsApp channel so that you can get access to our PDF notes, mock test and solutions. Okay, so without any further delay, let's get started here how to complete this chapter. So yes, we are going to divide it into three parts. In today's class, that is in part 1, we will be covering discovery of subatomic particles and atomic models. Okay, then in the part 2 we will be covering developments leading to Bohr's model and Bohr's model, and next one we will be discussing towards quantum mechanical model and the quantum model. Okay, so these all parts are very important. Questions can be expected from any of these parts. Okay, so if you see where year-wise weightage from 2017 to 2024, every year one question you can expect from this particular topic. Okay, so now with the first part today, discovery of subatomic particles and in atomic models. So in subatomic particles we are going to study discovery of electrons, charge to mass ratio, charge of an electron, discovery of protons and neutrons. Okay, then in atomic models we are going to study challenges after the discovery of subatomic particles, Thomson model, Rutherford model, then atomic and molecular mass number, isobar and isotopes, then limitations of Rutherford model. Okay, so yeah, so now coming to the first thing, that is discovery of electrons. So in this case, for discovery of electrons, there was one experiment that was done. Okay, and this experiment is called as discharge tube experiment. Okay, now what is a discharge tube? So see here, a discharge tube is a cylindrical glass tube like this, you can see in this image. Okay, and in this tube there is an cathode and an anode attached, and this tube is filled with gas. Okay, and what is the thing that you should remember about gas? So gas should be filled at low pressure. Okay, means very few amount of gas particles should be there in this medium. That is clear. So what is a discharge tube? A cylindrical glass tube with connected with cathode and anode, and a voltage is provided here, and there is a way in which you can pump the gases into the cylinder. Okay, so now what happens when very high voltage is given across this cathode and anode? Okay, when you give a very high voltage, the electrons, okay, so we do not know till now what is electrons. In Dalton's atomic theory we just studied that atoms are the fundamental particles of matter. But now what happened when we gave this high electric field is given, there was something observed. Okay, some rays were observed in this particular experiment. Okay, and when these rays hit this glass tube, it started glowing. Okay, so what we observed? The first thing we observed here are some rays were passing from the cathode to the anode. Okay, that is we don't know what is this. Okay, so but we could see some light, some rays passing through it, and when it was hitting on this side of the glass tube, we can see here some glowing, some glow was found on the glass tube. Okay, so based on that we came to know that we gave this rays name as cathode rays. Okay, so now let us see what are these properties of cathode rays and why we thought that these are which particles these cathode rays are made up of. We will understand. For now, just the story is like that. A discharge tube was there, and you filled the discharge tube with some gas molecules, and then you gave a very high potential, and you can see some lines, or you can find some rays going from cathode to anode. Okay, with apart from this we do not know anything. Okay, now let us understand about this cathode rays. So in this cathode rays, what is the first thing we observed? It started from cathode and moved towards the anode. Okay, it started from cathode and moved towards the anode. Now if you think in this way, then cathode is like anode, cathodes are negatively charged electrode, and anode is positively charged electron. The first thing that we observed about the cathode rays is it started from the cathode and was moving towards the anode. Okay, first point clear. Next, it is not visible, but their behavior can be observed with fluorescent or phosphorescent material which glow when hit by them. So in sometimes it was not visible on the way, but when you think when the glass tube was filled with was lined, you can say was coated with any fluorescent or phosphorescent material, it started glowing. Okay, next one, it traveled in straight line in the absence of electrical and magnetic field. Okay, so these rays were traveling in straight line in the absence of any electrical and magnetic field. Next, in the presence of electrical or magnetic field behave similar to that expected from a negatively charged particles, suggesting that the cathode rays consisted of negatively charged particles called as electrons. Okay, now what is this saying? Now we just saw that some rays were passing from cathode to anode, but now we provided some external electric field or external magnetic field. So due to this external electric field or magnetic field, these rays got deflected, and the way they deflected, it conveyed us that these rays contains negatively charged particles. We will also discuss now how it got deflected. Okay, next point, the characteristics of cathode rays is independent of the material of the electrodes and the nature of the gas present. So now we tried the same experiment by taking different material electrodes and by filling the gas tubes with different gases, but there was no change in the properties of the cathode rays. Clear? So these are the properties of cathode rays that you should know. The first property is it started from cathode and moves towards the anode. The second property is it was not visible, but when it hit the fluorescent or phosphorescent material, it started glowing. And the third one, it traveled in straight line in the absence of electric and magnetic field. Fourth point, when you provided some external electric or magnetic field, it deflected in such a way how the negatively charged particles will behave, which conveyed that these cathode rays contain negatively charged particles. And the fifth one, even if you change the material of the cathode and anode, or you change the the gas present in the discharge ray tube, okay, the nature of the cathode ray, the properties of the cathode rays were not affected at all. Okay, so now coming to this deflection which we are talking about. Okay, so now what we first, let us talk about the deflection. You can see here that this is your cathode ray. Okay, this is cathode, this is anode, and here this cathode ray is present. Now if this cathode ray, okay, is given in terms of this blue one and this yellow one is providing you electric field. Okay, so if you see, we just already concluded that this cathode ray is made up of electrons, negatively charged particles called as electrons. Now if you provide an external electric field, okay, if you provide one external electric field, then these electrons will deviate towards the positive electron because opposite charges attract each other, right? So what will happen if you put it in an electric field, the deviation, the ray will go and reach and strike at point A. Okay, and if you give some magnetic field where north and south pole is there, magnetic field if you give, it will reach at point C. Okay, now if there will be no field, okay, no electric field and no magnetic field, then the line will hit at the point B. Okay, now this deviation, how much angle it will deviate, that will depend on three important factors. What are these three important factors? Magnitude of the negative charge. So what is the magnitude of these negative charge will be the first thing on which the deviation depends. Second, mass of the particle. Okay, what is the mass of this particle? Third, the strength of the electric and magnetic field. Okay, so the strength of this magnetic and electric field that you are providing. So there are three factors on which the amount of deviation will depend. The first one is the mass of the particle, second, charge of the particle, third, the strength of the magnetic and electric field. Okay, so now if we see here, so this charge to mass ratio calculation was done by the scientist J.J. Thomson. What he said that if you do some calculation and if you give a certain amount of electric field and magnetic field in such a way, if you manage it, this line can be struck at point B. So based on calculation, he gave E by M ratio. Okay, so what is E by M? E is here the charge of electron, okay, and ME stands for mass of electron. Okay, so this value E by M ratio of the electrons was equal to 1.75 into 10 to the power of 11. Okay, so this value was given by J.J. Thomson. Next, coming to charge on the electron. So how to calculate the charge of the electron? So for that we have oil drop experiment. Okay, you need not go deep into the process and all of this experiment. It was done by R.A. Millikan, a scientist. Okay, Sir R.A. Millikan conducted this experiment and calculated that the charge of the electron is minus 1.6 into 10 to the power of minus 19 coulombs. Okay, and from the Thomson experiment we had already calculated the value of E by M ratio. Right, now we know, see, E by M ratio, if I know, was how much? 1.75 into 10 to the power of 11, and now I know the value of E. Okay, so I can calculate the value of M. So M was calculated like 1.6 into 10 to the power of minus 19 by 1.75 into 10 to the power of 11. So after this calculation we got the mass of the electron as 9.1 into 10 to the power of minus 31 kg. Okay, so let us have a recap of what we are studying. First we did a cathode discharge ray experiment and we found some cathode rays. Okay, now by adjusting the electric field and magnetic field of this cathode ray discharge tube, we found out the E by M ratio. Okay, now with the oil drop experiment by Sir R.A. Millikan, we were able to find out the charge of the electron. Now we had E by M ratio and the value of E. So by using both of this, we calculated the mass of the electron, which is 9.1 into 10 to the power of minus 31 kg. Clear? Okay. Next, coming to discovery of protons and neutrons. Okay, so protons were discovered on the same way using the same electrical discharge tube. Okay, so in this discharge tube, what happens this time? The anode, okay, so we had, this cathode was perforated. Okay, we used perforated cathode so that in the same way the anode rays can come and pass through this and hit the glass tube, and then we can find the glow of the glass tube. Okay, so the setup is same, everything is same, only the changes that we have done is we have used a perforated cathode. Now based on this, what are the properties of the anode rays? Let us see here. So unlike cathode rays, this is very important here. See, unlike cathode rays, mass of positively charged particles depend upon the nature of the gas present in the cathode ray tube. These are simply the positively charged gaseous ions. Okay, so if you remember the last point of the cathode rays were independent of the type of gas and the type of electrode used, right? But in this case, the anode rays were depending on the type of gas that is used. Okay, the charge to mass ratio of the particles depends on the gas from which these originate. Okay, so it charged, so because mass will depend on the gas originated, so that is why this value was different. Now some of the positively charged particles carry a multiple of the fundamental unit of the electrical charge. Okay, so the value, or you can say the charge of these particles were some multiple times of the fundamental unit of electrical charge. Means suppose whatever this positively charged particles were there, their charge were n times of, charge were n times of the fundamental unit of charge, that is 1.6 into 10 to the power of minus 19. Okay. Next, what we can see, the behavior of these particles in the magnetic or electrical field were completely opposite to that of the cathode or the electron rays. Okay. Now coming to the discovery of the neutrons, so it was discovered by the scientist. Okay, okay, that you should know. And the next thing here is like how was it, what was the experiment he did? So he conducted or he bombarded a thin sheet of beryllium by alpha particles, okay, and in this case we found out some electrically neutral particles having a mass slightly greater than the protons were emitted, okay, and these neutral particles were called as neutrons. Okay, so this was all about the discovery of electrons, protons and neutrons. So now let us have a quick review about their all masses and all. So if you see, electron symbol is E, proton is P, neutron is N. Electron charge is minus 1.6 into 10 to the power of minus 19. Proton is just opposite plus 1.6 into 10 to the power of minus 19. Now relative charge we say it is minus 1 and this is plus 1. Now if you see mass of them, it is 9.1 into 10 to the power of minus 31 in kg. Here it is 1.6 into 10 to the power of minus 27, and here it is also 1.67 into 10 to the power of minus 27. So you can see in the mass of proton and neutron, slightly we can say that neutron is heavier than the protons, okay. And next, coming to their mass in terms of atomic mass units, so it is 0.0054, 1.007, 1.008, okay. So now what are the values you need to remember? You need to remember these two values and the mass of the electrons, okay. These three values you should remember at any cost, okay. Now let us move to the next topic, that is atomic models. So now when in the Dalton's period, okay, so it was very clear that all the matter is made up of fundamental particles, that is atoms, right? But with the discovery of these subatomic particles like electrons, protons and neutrons, now a lot of challenges, a lot of questions arise in front of the scientist and in front of the science, okay. So let us see what were the challenges that came after the discovery of this subatomic particles. The first one was the stability of atom. So now inside atom there is negatively charged particles, there are positively charged particles, there are even neutral particles. So the question now arises is like, how can these particles stay together inside an atom and the atom is stable? Okay, how is that possible? Second question arises is about the behavior of the elements in terms of their physical and chemical properties. The third and the very important is the formation of different compounds by the combination of different elements. So you can find that certain elements bind with certain elements only, right? So you can find oxygen binding with chlorine, fluorine, like oxygen binding with carbon, like other elements like nitrogen and all, right? So and whereas some elements bind only with certain specific elements. So now the question is like, does this presence of atoms, like presence of electrons, protons and neutrons inside that cause any problem or cause anything, is the reason why is the factor which depends or which decides the bonding of these atoms. The fourth one, understanding the spectra, okay, the spectra of different atoms, is it affected or influenced by the presence of these electrons, protons and neutrons, okay. So coming to this, the first scientist who gave the model for the atom was Thomson model, okay. It is a very simple model. According to Thomson, he said that the atom is a positively sphere, okay, it's positive sphere where the positive charge is distributed everywhere uniformly, okay, and the negatively charged electrons are embedded on it, okay, are embedded on it. Clear? And in this way he was able to explain the neutrality of the atom. Yes, so we have positively charged sphere and the electrons are embedded on it, and this model was given different names also, like plum pudding model, raisin pudding or watermelon. So it was compared, like in plum you have raisins in between, so plum is your positively charged sphere and the raisins are the negatively charged electrons. Similarly in watermelon model, the red part is the positively charged sphere and the seeds in it are the negatively charged electrons, okay. So this model was going well, okay, it was able to explain the stability of atom until the next scientist came, that is Rutherford model. So Rutherford gave his atomic model based on some experiment, that is gold foil experiment, okay. Now what is this gold foil experiment? So in this gold foil experiment, you need to remember three components were there. What was the first? The first component was a source, okay, and this source could emit alpha particles, okay. The second thing is the alpha particle. Third thing we required was a gold foil, okay, and the fourth one was a detector. Clear? We need four components, or I can say three components: a source that could produce alpha particles, gold foil, and then detector. Okay. Now what happened? These alpha particles were bombarded on this gold foil. Okay, and after that we found three different types of observation. So the first observation here was most of the alpha particles traveled through the foil without any deviation. So you can see these alpha particles traveled through the foil, and when they hit this detector, it started glowing. Okay, so you can see most of the alpha particles travel straight through the gold foil. Okay. Next, second observation was some of the alpha particles were deflected by some angles. Okay, so this you can see in this that is B. When these alpha particles came here, they got deflected by a small angle. Okay, and the C, or I can say next observation, that is occasionally an alpha particle travels back from the foil. Okay, so very few alpha particles were seen when they are traveling back. Okay, they just, you can say, reverted back towards the source. Okay, so this was very less, or you can say very few particles undergo this way. Others, most of them moved straight through the gold foil, and very few of them got deflected. Okay, now let us see these observations and what conclusion we can take it from here. Okay, so the first observation, as I told you, most of the alpha particles pass through the gold foil, okay, undeflected. They pass straight through the gold foil. Now what is the conclusion here? That means that most of the space in the atom is empty. Okay, so if you see, like if the alpha particle is traveling straight without any deviation, that definitely means that there is no obstruction in the atom, right? So that can consider that this atom space is completely empty. The second conclusion, or the second observation, was small fraction of the alpha particles was deflected by small angle. Now what this give you a conclusion? That there is something positive present at the center. Now why positive? Because these alpha particles are also positive in nature. Okay, they are helium-2+ atoms. Now when they hit another positive particle, then only they will get deflected, right, due to repulsion. So we can consider here that something positive is present at the center. The third observation, that is very few alpha particles bounced back and were deflected by nearly 180 degree. Now what does this conclusion? This gave you the conclusion that nucleus is very small compared to the atom. Okay, so the deflection when they turned, or you can say reflected by 180 degree directly, this gave us the conclusion that that nucleus which is present is very small and very heavy present at the center of the atom. So based on these observations and these conclusions, Rutherford gave the model of the atom. So according to this, what is the first point? The positive charge and most of the mass of the atom was densely concentrated in the extremely small region called as the nucleus. Okay. Second, the nucleus is surrounded by electrons that move around the nucleus with a very high speed in circular path called as the orbits. Okay, so the first point is saying that inside the atom, okay, inside the atom there is something positively charged sphere is present. Okay, and most of the mass of the atom was densely concentrated here, and this positively charged sphere is called as nucleus. Okay. Next, the nucleus is surrounded by electrons that move around the nucleus with a very high speed in circular path called as orbit. Okay, so these electrons move around the nucleus in circular paths called as electrons. Okay. Now third one, electrons and the nucleus are held together by the electrostatic force of attraction. So this nucleus and electrons, so we were talking about the stability of the atom, right? How these electrons and nucleus are present inside the atom. So these nucleus and electrons, because they are positively charged and negatively charged particles, so there is a electrostatic force of attraction between them. Okay, so that's about the Rutherford model. So now we are coming to the next topic, that is atomic number and mass number. Okay, so now you see here, what is atomic number? So atomic number, okay, this is represented by Z. Okay, and what it is exactly? So atomic number is the number of protons. Okay, and next topic, if you see, that is mass number. Okay, and mass number is denoted by the letter A. And what is the meaning of this mass number? This is the sum of number of protons plus number of neutrons. Okay, number of protons plus number of neutrons. Now this proton and neutron together are called as nucleons. Okay, number of protons and neutrons are called as nucleons. Okay, so now for example, if I see, like I write an example, nitrogen, or I use sodium 11 and 23. Okay, so now what does this 11 represent? 11 is the number of protons. Okay, and 23 is the number of protons plus neutrons. Okay, so now if you know that number of protons is 11, okay, then what will be the number of neutrons here? So number of neutrons will be 12, right? So I can say that protons is 11, neutrons is 12. Okay, and the total number, or I can say the nucleons, is 23. Okay, fine. Next, coming to isotopes and isobars. So this is also very important. So now what is isobars? Isobars are the atoms with same mass number but different atomic number. Okay, same mass number but different atomic number. So you can see in an example here, carbon 6, 14 and nitrogen 7 and 14. So you can see these mass numbers are same, okay, but these atomic numbers are different, right? So if we have same mass number but different atomic numbers, we call them as isobars. Okay, now if you see the protons neutrons number here, so first of all, if I see the proton number, so here it is 6 and here it is 7. Now neutron number will be this minus this, right? So this is the sum of proton plus neutron. So 14 minus 6 is 8 and 14 minus 7 is 7. So what another definition I can give for isobar is, isobar are the atoms with same, you can say same number of one second, we have here same number of, okay, sorry, one second. So you can define it as the same number of, they have same atomic numbers, sorry, they have same mass numbers but different atomic numbers. Okay, so next what we can see, their proton numbers are different. Here proton number is 6, here the proton number is 7, here the number of neutrons is 8, here the number of neutrons is 7. Okay, now coming to isotopes. So isotopes are the atoms in which they have identical atomic number. Okay, they have identical atomic number but different atomic mass number. Okay, so now here also you can take one example of, here it is carbon 14. Okay, so C612 and C614. Okay, so now if you see here, we have protons and neutrons number. If I tell you, so proton is 6, here also proton is 6, neutron is 6 and neutron is 8. Okay, so proton number will be 6 and 6, neutron number is 6 and 8. Okay, so now this one, another example we can take, like you can have hydrogen 1 1, hydrogen 1 2 and hydrogen 1 3, right? So if you see the number of protons and number of neutrons here, right? So protons are 1 in each case, okay, and neutrons are like 1 minus 1 0, you have 2 minus 1 here 1, and 3 minus 1 2. So the number of protons is same, but the number of neutrons are again different. Okay, so same atomic number, different mass number is called as isotopes, and same mass number but different atomic numbers are called as your isobars. Okay, so yes, with this we have done almost the most of the topic. Now just let us understand a very important concept, that is limitation of Rutherford model. So if we understand Rutherford model was like, Rutherford was able to discuss everything about the nucleus, about the electrons. Okay, so Rutherford model was mostly considered like a solar system, like sun is the nucleus and the planets revolving around the sun can be compared with the electrons. Okay, so but what happened here is, the first limitation is it could not say about the stability of the atom. Now what is there, how cannot it explain the stability of the atom? So you can see that we have a, suppose we are having a nucleus here and the electrons are moving, right? Now according to the Faraday's law, okay, an accelerated charge particle loses energy. Okay, an accelerated charged particle loses energy, or you can say emit radiation. Okay, clear? Loses energy or it can emit radiation. Now what happens? Now you see that if these charged particles are so because these charged particles are moving, right, the direction is changing, so we can say that these charged particles are under acceleration. Now if there is under acceleration, they will lose energy or they will emit radiation, and finally one day they will fall into the nucleus. Okay, so one thing we can tell, that why let us not consider that electrons are not moving, let the electrons be stationary at their positions. If we talk in that way also, due to this force of nucleus, okay, nuclear charge or nuclear attractive force, these electrons will fall inside the nucleus. Okay, so that is why the stability of the atom was not explained well by the Rutherford model. Now coming to second one, says nothing about the distribution of the electrons around the nucleus and the energies of these electrons. Okay, so we do not know, like in each orbit how many electrons should be there, how are they moving, what is the energy of their, nothing about in these topics were discussed about the Rutherford model. Okay, so these were the two limitations. So now let us do some questions. So this question I gave you homework in my previous lecture from the previous chapter. So this was a little tough question. Let us understand how to solve this. Okay, so a gas mixture contains 25% of helium and 75% of CH4 by volume at a given temperature and pressure. The percentage by mass of methane in the mixture is approximately. So this was asked in 2020. So it's a little, I can say, lengthy and a difficult question. So first of all, we can see that if the total volume, okay, if the total volume is 100, okay, then we can say out of that we have helium as 25%. So I can write 25% of 100 is 25, and methane as 75. Okay, so next what we can have is the percentage by mass of methane. So next, if you see number of moles of helium, that will be equal to 25 by 22.4. So that is equal to 1.1. Next, number of moles of methane, so this will be equal to 75 by 22.4, and that is 3.3. Okay, so now if we see number of moles of helium and number of moles of methane are already given to us. Now we have already calculated. Now let us calculate the mass of this. Okay, so mass of helium will be equal to 1.1 into 4, that is 4.4, and mass of methane, CH4, that is 3.3 into 16. Okay, so this one will give you, I can calculate this one. So we will get 16 into 348, 16 3s are 12, 40, so we will get 52.8, right? Yes. So now if I Again I can calculate this one. So to total mass, what I can say is total mass will be addition of these two. So we'll get this one 4, 5, 6, 7 and 57.2. So what is the percentage of methane here? So percentage of methane, you know, mass of methane is 52.8. So 52.8 by 57.2 into 100. So if you calculate this, we'll be getting around 92%. Okay. So the correct answer for this question will be option number B. Next, we'll solve questions from the today's lecture. So which of the following statements you think is wrong regarding the alpha particle scattering experiment? So that is your gold foil experiment conducted by Rutherford. So alpha particle mostly move through the gold foil having zero deflection. Yes, this is correct. A small fraction are deflected. Yes, this is also correct. 1 in 20,000 turns 180 degree. This is also correct. And the thickness of the gold foil is 100 micrometer. Okay, this is wrong. It is around 100 nanometer. Okay, so the incorrect statement is option number D. Next, if the number of protons and neutrons of an element are 13 and 14. Okay, so number of protons I can write is 13 and number of neutrons is 14. Okay, then what is the value of the atomic number and mass number? So atomic number is same as the number of protons, so that will be 13. So we can eliminate these two. And next, if you see the number of that is your mass number is the addition of these two, that is 27. So correct answer is option number B here. Next, pick out the isobar of argon 1840. So isobar should have same mass number. So you can see here we have same mass number and different atomic number. So option number C. Next, find out the number of neutrons, protons and electrons in this particular compound, that is chlorine 17 and 37. Okay, so we have the same what is the number of protons? We can easily find out. This is the number of protons, that is 17, right? So you can see all these options are having 17, so we can eliminate this option. Next, the number of protons and number of electrons is always equal in a neutral atom, right? So you can see that this is a neutral atom. It doesn't have any charge, so the number of electrons will also be 17. So these are there. So we can eliminate this option. Now to calculate the number of neutrons, this is what? Neutron plus proton, and proton is 17. So I can subtract 37 minus 17 to get 20, and we will get 20 as this one. So correct answer is option number C here. Okay, next, which of the following statements is not correct regarding the cathode rays? Okay, so cathode rays originate from the cathode. Yes, this is true. The charge and mass of the particles constituting the cathode rays depend upon the nature of the gas. Yes, depends on the nature of the gas. This is incorrect, right? So we have discussed that in anode rays it depends upon the nature of the gas, but in cathode rays it does not depend. So yes, this is the wrong statement. Next, the charge and mass of the particles constituting the cathode rays do not depend on the cathode's material. Yes, this is correct. They possess kinetic energy. This is also correct. Okay, so option number B is the correct answer here. Next, in the determination of charge to mass ratio, the deflection of electrons from their original path. Okay, so the deflection depends on what factor? So we have discussed that deflection depends on the charge. Next, it depends on the mass, and next it depends on the strength of electric field and magnetic field, right? So in the determination of charge to mass ratio, the deflection of electrons from their original path increases with the increase in the voltage across the electrodes. Yes. Increases with the decrease in the voltage? No. Decreases with the increase in the voltage? No. Does not depend on the voltage? No. So option number A is the correct answer here. Okay, next question number 7. According to the Thomson model of an atom, the mass of an atom is assumed to be uniformly distributed over the atom. Okay, option number A. Next we have question number 8. Rutherford experiment on the scattering of alpha particles showed for the first time that the atom has electrons, protons, nucleus. Okay, nucleus was discovered with the Rutherford experiment. Okay, so this is a homework question for you now. The ratio of neutrons in carbon and silicon with respective atomic masses 12 and 28 are. Okay, so you have been given with the atomic masses, you need to calculate the ratio of neutrons. So I hope you can solve this question, and do not forget to comment down the answer. Thank you for watching, and please subscribe the channel. See you soon in the next class.